Hello everyone, how are you doing? This is part 8 of our project, and for a few weeks we're gonna have a look at materials. We've seen it in the basic series. Materials settings can be found in the Material Property tab in the Property panels over here. And last time we had a look at base color, metallic, and roughness settings. Okay? You can see that if we want to create advanced materials, this is not enough because we only have simple values. I haven't talked about the interface so far because I think it can be distracting at the beginning, but we are gonna modify it a bit. So look at the dark line in between panels, and if you move your mouse over it, you can see it changing its shape, meaning you can resize the different panels the way you want. So if you want to do more material work, what you can do is either going here at the top, where you've got a lot of presets for the interface layout. You can go to the shading presets, and then you will have at the bottom here in this area shader editor. What I like is to start with the normal layout, and if I move my mouse over this dark line, meaning I can either modify the scale of the windows, or if I click on my right mouse button, I will have the option to split the view, and I want a vertical split. This way, now I have two 3D viewports, and what I can do, you can find it on every panel. In the top left corner, you've got a button, and this allows you to change the content of the panel. We are looking for the node editor or the shader editor, and so if we click on this, we've got one. I'm gonna scale down the 3D view and zoom in just on our cube, and here on this side I have now the shader editor. I can close this area here because we don't need it yet, and now I'm gonna give you an overview of what it is like. For me, this represents an easy way to understand how the nodes work. Keep in mind that this is not the way it is explained or laid out in Blender itself, but I found it easier to understand, so this is the way I divide the nodes category. We'll have the first one, which is coordinate. This determines where is displayed all the result of these nodes on the object itself, on the 3D objects. You've got inputs. That can be something as simple as a color or a value, or something a bit more complex that are called texture or even images. Then you've got converters who will take one or several inputs and outputs a different value. Then you've got the shaders, which determines the behavior of the lights depending on the inputs that you plug in, and it will just output a result. And finally, you've got the outputs that will display the results in the 3D viewport. To start, the navigation inside the shader editor is the same as the one in the 3D view, meaning you can scroll your wheel mouse up and down to zoom in or out. You can pan your view using the middle mouse button. You also have an add menu at the top where you will find all the different nodes that you can add. Okay, and you've also got what is called friends that can allow you to organize your nodes. And you can also delete any node or object in the shader editor. So to start, we're gonna see that there are 4 kinds of colored dots, either on the left or on the right of the nodes. We're gonna start with the gray ones. A gray dot, input or output, means you have just a single value going through it. This is like having a value here from the hotness, let's say, from 0 to 1 or so on. It's just a single value. The yellow dots are for 3 values, which are mostly used for colors. And you can see that if I want to change my color here, you've got 3 values. R for red, G for green, and B for blue. So you got 3 values outside of this. And finally, you've got also the blue dots, which also contains 3 values, but are about vectors, meaning position in the world. And they are expressed with not RGB like the color, but X, Y, and Z. The same axes that we have in the 3D world. Okay. And the latest one is the green one, which is called the BSDF, which stands for Bidirectional Scattering Distribution Function, which is the formula that determines, as we said before, the behavior of the lights. And usually we tend to connect an yellow output to a yellow input, and so on with the same colors. Of course, there are exceptions to every rules, and I will try to cover it all, little by little, in the next lessons. So, to start, I have now this plane here that will display the results of what we have here. First, to be able to see the shader on this plane, the most important thing to have is to have something connected to the output. So I will start connecting my shader to the surface, meaning it is displaying in the surface of the object. On my 3D view, I have to make sure I have activated the material preview shading mode so that I can see any material that is assigned to this object. And now if I modify, for example, the color of this material, you see that the object is the same color. For that, we can also use an input and hold your left click on the output dot and drag it all the way to the input of the shader. And now this value is controlled by this input. I can change the color of it and then the brightness of it here. Or I can modify the values here if I want to. We also add something like the metallic value, which goes from 0 to 1. Okay. I can take a value input and then drag the output of it and plug it here. So now it's at 0. I can go. If I go over 1, of course, the result will be only 1 because it is limited by the range of what the metallic slider can handle. So going over 2 doesn't make any difference than having 1 as a value. Okay? And then, for example, the roughness can be driven by a texture. Textures, you've got 2 different types of textures displayed here. One is called Procedural Texture, which means that what it creates is based on math formulas, meaning that if I unplug all this and all this here, okay, and I plug this texture as the base color, you will see it will display something here. Because it is a formula, you also need to tell the shader where it is displayed exactly on this object. For that, you can use the coordinate. I'm gonna use the object outputs, and because it is a blue output, I'm plugging it into the blue inputs of the Musgrave texture. And here I have something like that. Okay? The difference between this type of texture and an image texture, this one is called Musgrave Image because that's the name I've given it, is that because this is driven by a formula, a math formula, the procedural one, if I zoom in very close, you can see that it's still smooth and perfect. But if now I'm using the image instead, you will see it's the same pattern because I created it based on this Musgrave texture, but if you zoom in very close, you will see after a point that the pattern is like that because it is limited by the resolution of the original image. This is not a math formula, it is made out of pixels, so it has these limits in quality. That's why most of the time I'm gonna show you what we call procedural materials, meaning we're gonna use mostly math formulas based textures. Okay? So now what I can do is use a color here, a value here for the metal, and maybe for the Musgrave texture use it in the roughness. Meaning this will give the roughness different values based on this texture. If you look at this, you can see that you've got some kind of wavy shapes, and on this side it's much more reflective, almost like a mirror, and on this side it is not. If you remember from the Blender Basics lessons, what is highly reflective is a value of 0, and what is less has a value of 1. Something to keep in mind is that colors, as well as vectors, also can be represented by values. If you look at this color and go here, you've got the R component, which is the red component of the color. Its values goes from 0 to 1. Okay? And you've got the same kind of values when using something going from black to white. Okay? Black has a value of 0 and white has a value of 1. Meaning that the texture here, if I plug it to the base color, you can see where it was reflective before, we have a black area, and where it wasn't, we have a white area. Meaning that if you plug it here in the roughness, if I remove this, we are metallic. Okay, so you can see again this area is highly reflective and this is less. And so then you've got the converters. Converters means that if you take one or several inputs, let's say here, I'm plugging this color into this converter, and I'm gonna plug the output of it into the base color, you can see that if I have something like that, which is a kind of orange salmon color, if I mix it with a white, with a factor of 0.5, meaning a middle, this is what we have, a brownish color. If I go all the way to 1, I got my white color. It doesn't look like white because it's reflecting the environment. Now it's white. And this allows me to mix together two colors. If I want to mix my original orange color with the blue, orange and blue almost in the middle gives this kind of pinkish color. And you can see I can go from one to the other. Okay, you got the same here with the value. Okay, I can have a value of 0, for example, as a start. If I plug it to this add node, and I say, okay, well, I've got an entry of 0, and I add the value here of, let's say, 1, then if I plug it to the metallic part, you will see that the object will be fully metallic. You will see it better if we lower the roughness. Okay, like a mirror. And if I add the value of 0, the result will be 0. The final output value will be 0. Okay? If I unplug it, see there is no change because it was 0. And then you've got the last converter. If I plug something here, well, at the beginning this converter is supposed to be like that. If I plug this here, before we would see that it was looking like that. Okay, this converter, which is called color ramp, will take the original values, and what is black here will be the value which is here. At the moment it's black, and what is white here will have the value of what I set here. Now, if I plug it here, and I put the roughness at 0.5 so that we have the same kind of results that we had before, you can see that it doesn't change because this Musgrave texture is a black and white image at the beginning, and this just says the black at the entry is black and the white is white. But look, what we can do is just say the blacks from the original image, from the input image, are not black anymore. Let's say I'm gonna give them a blue color, and now the blacks are blue and the white can be white, or it could be red, for example. And this then modifies an entry color and then transforms its value to the one that are here. Can modify the values of both sliders, but we can also drag them like that. Okay, and if you've seen this, that means when I drag this, all the values from the input image that are here from black to maybe gray, now they will be blue. That's why you can see that the blue is eating away at the red area, because in between there was some gray, but now, because I have the slider here past the 0.5 position, so past the middle, that means all the grays are now blue. It will be the same if I move this red slider here. You can see at the moment here in the middle we got some kind of purple color, which is what is between the blue and the red, and if I move the red closer to the blue slider, you can see it almost disappeared. And you can also add another slider here that will act as a kind of gradient. I can make it green, and see now the gray areas of the image are now green. and then you've got values in between the green and the blues and the green and the reds. Okay, so that concludes our introduction to what shaders are. I hope this was simple enough to understand, because now we're gonna tackle complex materials using this workflow and not this panel anymore. Enjoy creating materials on your own. I encourage you to start trying out for yourself all of this, because it can take time to really assimilate how it works if you're not used to using this kind of systems, meaning the nodes. So have fun, and I'll see you next time. Bye.